Okay, my friends, today we're going to be taking a special trip through the universe. And we're going to look at all of the things that exist within the universe and see if we can understand what they are. What's all these things that are floating around out in space? You got the asteroid belt, you got the Kyper belt, you got meteorites and asteroids and comets and all kinds of debris out there, and dust and particles and everything. Where do they come from? What literally are they? We're going to be looking at all these things that are out in space, and I'm going to tell you right now, I think I understand them, and I think you will too if you pay attention and look at the details. The details are where you find out the origin of things. You can't just look at something and make a big broad guess and just walk away. You have to, and I say this in all of my research, if you don't know everything about something, you don't know anything about it. You can't just say, well, we figured everything out, but there's a bunch of stuff we don't understand. No, that doesn't work. Why would the other stuff be fully understood and the rest of it you just can't understand? You have to be, if you can fully understand one part of it, it should lead you to understanding the rest of it. And one of the things that we're going to be looking at today is the Van Allen radiation belt, because that proves my electron flood theory. I move everything into everything else. Nothing sits by itself. Everything overlaps. And that's what we're going to look at, the overlap of everything. And I'm going to tell you right now, it's just shocker du jour all day long. So this is going to be a little bit of a test for your ability to open your mind. But when you see the evidence and then you close your mind, I will have no respect for you. If you can say, Roger, that's not right because of this, this, or this, not just, Roger, you're an idiot, which is what I've received for my whole time of doing this research. So, you know, if you can make a good counter argument against my evidence, present it. I'm ready. But just to say that everything, oh, that's all just fake stuff, that's all lies, no. All right, my friends, this is going to be really hard. I'm finding it a hard time to get started with this because of all of the opposition from everywhere. I'm just going to present the evidence. You take it or leave it. Okay, I'm hoping we have some new people on board here which haven't seen this yet, but this is asteroid Psyche. It's a metal asteroid. This is asteroid Bennu, which they just went up, landed on it, and took samples back to Earth. This is a heart, and so are these. I'm telling you, that's just what it is. These hearts have all kinds of, it's exactly a heart, and hearts are nothing but blood, and blood is nothing but metals inside of plasma. The plasma boils off and you end up with the metals. Now, in addition to that, hearts, we have this, because these are asteroids. Now, this is in the Kuiper belt, which is way out there, just before the Oort cloud. And this is about as far away as you can get from the Earth. And this, I'm going to tell you right now, is an enthesis, and I will explain that in a minute. This is Comet 67P, just roaming around, and this is the comas given off by 67P because it has an artery and it has blood vessels, and that's the size of the artery, 500 feet across. It's just absolutely enormous. This is Comet 67P, the same comet, sitting on top of Raleigh, North Carolina. So we're talking about big, big things in space. And Comet 67P is exactly this. It broke right off here. All right, and it's from, it looks like a hip joint to me. And I don't know what these things are. I mean, I don't know what creature they came from, but that's a hip joint. That's the ball and socket part. This is the neck, and this is the little stem that comes over, and it fractures right along here. All right, and then outside of this, you've got your artery, which is here. This is a huge, huge artery, 40 meters across, 40, 80, 120, 160 meters. All of these little balls are the entrance, little blood vessels that go in to service the blood supplies that are around there to keep the thing alive when it was alive. And this is the same from a different shot. They were actually had a lander up there that landed on here and did some chemistry, and I looked into this very carefully. This is a bundle of tendon, or it could even be muscle, but I think it's still tendon. And this is what happens inside of these ball and hip sockets. You have a couple of little bundles pulling it this way, pulling it that way, letting it twist this way. And that's what these tendons do. These are the tendons. And this is another bundle of tendon, and maybe pulling it back this way so it can twist and it'll get pulled back. They're complicated. They're a complicated little device. And here it is in its entirety. That's the ball. That's the socket. And it breaks right off here. Breaks right off here. And these are all these little tendons. You see them? They're going all over the place. And that's why there's a bundle that hooks right up to that ball as well. Very complicated little device. It works pretty good unless you break it. When you break it, you've got some problems. And they break in a couple of ways. They can break right here. They can break way up here. This is what 67P is a break way up here. And then, of course, I showed you the hearts. That's a heart, that's a heart, and this is also a heart, because that's a real heart. This is the valves they have in them, which is up here in the aorta and so forth. And then this white strip around here, you see it? That's the tendon that locks it in so the muscles can go loop, 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 and pump your heart all day, but this has to anchor the muscle. And this is exactly what you find on Bennu right here. There it is. There's your valves. There's your anchor, which is the tendon. You can even see the little tendon spots coming down right in here. You see them? They actually went up here and landed right on there and took some blood, and literally blood, because that's what it is. This is a heart. That's blood. Everything I have found, 100%, is made of biology. Even the asteroids and the meteorites, and I have meteorites right here. They're made from blood too. Like this is a little tiny lung. All right, it's a magnetic meteorite. And the reason is because it came through space and boiled off all of the cheap stuff and ended up with the metals. All right, so you end up with a magnetic meteorite. And they're not magnetic, they attract magnets. Think of it that way. And they all do, because that's what happens as they burn up coming through space. Now, there was this one here. This is nothing more than a lung. You see that? That's a gigantic iron lung. It was originally a lung like this. Coming through space, all the blood that would be in there, all that red stuff, turned into metal. And all the cheap stuff blew away. And you ended up with this iron meteorite. And right down in here, you can actually see there's still a little tiny red spot right there. You see it? That's a blood vessel. That's where the blood is being pumped through. This, I'm going to tell you right now, you could probably get some kind of, I don't know, the heat would be extreme on this, so I'm not sure any of the chemistry would be very good, but the metals are still here. And you can see the texture. You can see it's a iron meteorite, which iron comes from hearts and lungs. And also, let me show you this one here, which is I believe this was a liver. Livers are still loaded with lungs too, but they don't have all those pockets and holes, so you end up with a solid chunk of metal. And this right here is the red blood. You see right there? That's the red blood. That's an artery. What's it doing inside of a meteorite, an iron meteorite? Well, it was at one time, it was alive. And this is where the black blood is, where the vein blood. And all of these different crystalline patterns are different types of metals. And it's smelted coming through, which means you just burnt off all the cheap stuff and you end up with the metal. And then when they etched it, I'm sure they etched it with a little acid or something to bring out the highlights, and there it is. So these things that are in space are not just rocks floating around out there that have no purpose. They were alive one time. I can't find a single thing that wasn't alive. This is a maro. That's a fingertip. Well, it's a complete finger. That's the joint right there, right there. This is grip skin, the heavy-duty skin. I've shown this hundreds of times. Grip skin is different than the skin underneath, the flesh underneath. This is where your tendon tags in. That's the tendon. Runs right down to the investment part here. Hold on a second. Well, hold on. Well, I really don't have a good piece of bone to show you that shows it well, but this is the investment part. You see, like down here where you got all these little holes in a bone. You think, well, what is all that about? This is the reason this is green. I was doing some experiments with different chemistry, but anyway, what happens is the tendon comes down here, but then it's got to lock in. That's where it locks in. That's where the tendons lock in, into all these little balls, these little cavities. And then this is the seam, and then that's the other part of the tendon. This is your knuckle. It's actually your knuckle right there. And right there, the black and the white, these are the vein and artery. That's the vein. The arteries over this side. These two here are the tendons. See the big tendons runs up your fingers? That's what it is. They run right over the top and all the way up to the end where you have the grip skin. So that's a maro. And, you know, Avi Loeb from Harvard certainly won't speak to me about that. Nobody will speak about anything. Nobody from the NASA, JPL, none of them. They don't want to talk because it takes away their status and ruins their funding. Because this is just all nonsense what they're doing. Now, this is the actual chemistry they did on 67P. This is nothing more than body chemistry. Hydrocarbons, carbon, iron oxides, the different iron oxides, which is with your blood. In your blood, you have different iron oxides. You have Fe2O2 and Fe2O3, different oxides. You've got your sodium, your silicon, hydrogen, carbon. It's all biology. And they said the same thing. They said, yeah, that's just all basically biology. We don't know what to say about it. Have a nice day. We're going home. That's it. And look at the size of this. You see the size of this on top of Raleigh, North Carolina? Here's what it is looking close up. Here's where they landed, right down in here somewhere. 200 meters is this size. Just think about it. It's 200 meters, 200 meters, 200 meters coming up there. That's a very, 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 very big hip joint. And there it is right there. That we were just right down in here, this little bitty down in here. All right, so we got a lot to look at. We're just going to go, and then I went into some other stuff in the microscope. I just sort of bumbled around after a while because, like I say, it's a deep rabbit hole, and everything has to make sense. And now, to me, it does make sense. Okay, my friends, we all know about the rabbit hole. Well, I started to look into some of the debris that's in space today, and I looking up the Kyper belt and some of the objects that are in the Kyper belt, and I find out they're basically the same thing that I've been looking at everywhere else. I'm telling you right now, it's biology. Now, that led me down a rabbit hole that just kept going and going. So this is sort of a little mix of this and a little mix of that. But you're going to see the things that are in the Kyper belt. And one of these objects I'm going to show you extremely carefully is a piece of biology. Okay, this is the official narrative here. They say that located in an area of the outer solar system, just beyond the orbit of Neptune. It's quite a ways out there. It's called the Kyper belt. Contains hundreds of thousands of icy bodies. Now, they're not talking about ice, I don't believe. It's rather unexplored region of space, and the Kyper belt provides an intriguing cosmic mystery. Nobody knows what's going on there. For some unknown reason, it abruptly ends roughly about 50 astronomical units from the sun. And nobody knows why. All right, it's puzzling because theoretical models predict an increase in the number of icy bodies, not instant stop. Instead, the rocks, so they're talking about being rocks, stop. The drop-off is so dramatic, the feature is of nothingness after. There's just none whatsoever outside this one exact spot. And I will show you the same exact things that happens in a centrifuge. And that is nothing more than a centrifuge. So the drop-off is so dramatic, the feature of nothingness exists outside the Kuiper belt, has been named the Kyper cliff. All right, so nobody knows about it. It was only in 1950 that they predicted it, and they didn't discover it until 18 years later. So let's look at it and see if we can figure it out. Okay, my friends, get ready for this. We are going to try to discover what's going on in the solar system and what's going on with the Kuiper belt, which is a whole series of asteroids out there, and it goes out and then it just stops. And they have no idea why. They say this should not be happening. It's a big, huge mystery, and they cannot account for it. And so they're saying, why does the Kuiper belt suddenly end? Now, I'm watching a video about it, which I'm going to refer to, and again, it's a Fair Use Act. I'm not trying to steal anything, but they have an opinion that they're talking about with an extra planet affecting it and sort of pushing it into this configuration where it's just a very, very abrupt stop. Now, I am not going with that, and I will tell you why, as electron flood theory would not allow for that whatsoever. And this is the new dipole electron flood theory, and I will show you the influences that will happen, the push to shove, the attraction, the repulsion, and what is the Kuiper belt made of? What are these objects out there? Where'd they come from? And there's all kind of theories about that. So, and this is fairly, I mean, it's not brand new, but it's not that long ago that they discovered this Kuiper belt. So let's get into a discussion about it. But don't forget, nobody knows. Puzzling objects found far beyond Neptune hint at a second object out there, planet or something. Why does the Kuiper belt end suddenly? Why does the Kuiper belt end so suddenly? Nobody can answer that question right at the moment, other than speculation as to some other planetary influence. And the way they are portraying it, I think they have it exactly opposite. I don't think it would push them. I think it would attract them. What we're seeing, I believe, is the exact same effect as a centrifuge, because we are nothing but a huge, huge, huge centrifuge. And there is such a thing as called specific gravity. And in that specific gravity, everything separates out according to its weight. And then it just abruptly stops. And I can show you this. It's very simple to show this. And I don't know what these objects are out there, but we have a situation with our own Earth where the silicon, there's a fluid layer of silicon. It's a couple of 100 miles thick, way down in the ocean, underneath the salty waters. And the reason it's down there is because it's so dense. Silicon is heavy as hell. I mean, silicon gets in its fluid form, it's very heavy. So, and then that would just settle down, because we're nothing more than a centrifuge as well, basically. For fluids, for sure. So these fluids are separating according to their specific gravities, basically, and on the surface is where we have our water, the best water. So deep down in the oceans, you're going to have more dense thicknesses of liquids, and it just happens that the silicon is a very dense liquid. All right, so let's get started. Okay, so let's see if we can figure out what's going on with the Kuiper belt. As you can see here, this is whole blood. And whole blood contains all of these different metals. All of these different metals. Plus a bunch of other stuff. And mostly water, but the water evaporates off. But you're going to be left with these metals. Now, This is the periodic table of elements. All right, these are all the different types of atoms, and they get bigger and bigger and bigger and bigger, and that's these different little, signatures of what these are. And there's iron, and there's vanadium, and there's all of these, and the one gets bigger and bigger and bigger and bigger. Now, when you do a centrifuge, what happens is something called specific gravity. So as you spin that thing like crazy, faster and faster and faster, the heavier stuff just keeps going to the bottom, and the lighter stuff keeps coming this way. So it's a complete separation, and there is a cliff that falls off in the blood that's just exactly like they're talking about a cliff that falls off with the things that are in space. Now, I'm not saying there's blood out there. I'm saying that there's something that as we spin, it's nothing more than a centrifuge. Now, the only thing I can't really think for sure why they wouldn't just keep going. I have to admit, that strikes me as a little strange, but I do feel that it's got something to do with its centrifuge, and at the same time, gravity. So the two of them are working together. The gravity of the solar system pulling on it, and the push of the centrifuge throwing it out creates this. That's the only thing I can think of. And nobody else can think of anything better, so. All right, so here is the centrifuged blood. They put that tube in a thing, and it sticks out. The tube just sticks in there, and it's just all blood. They're all red, and it just looks like normal blood. And then they turn it around, spins and spins, and it just keeps spinning, spinning, spinning. And before long, this happens. And that right there is the cliff between the plasma and the red blood. Now, not only that, the red blood is just not red blood. The densest metals will end up going down to the very, very bottom. Because you saw what the blood is made out of. There's at least 30, 40 different metals in there. And they're going to be, the densest one will be at the bottom, and they'll be worked their way up from there. And then at a certain point, as very, very abruptly, it changes into the plasma, which is the watery stuff. All right, and that's exactly what's going on in the solar system. Everything is further away and further away and further away, and then by the time you get out to the end, I think this is what we're getting is they're just being thrown to the end, and for some reason they're stopping. I gotta admit, this is kind of a mystery, but I like mysteries, so I'm going to dig a little deeper. All right, what you're looking at here is the tibia and the fibula, basically. Fibula and the tibia. Now, there's a little wrinkly stuff on the outside, and then you go into the real flat, smooth bone. And then you have a little thing that goes over here, and this bone attaches. Now, here's the way it attaches. There's a ball right in here, and a little tiny stalk, and then there's a ball right in here, and that allows them to rock back and forth. And here is this exact same piece. It even has this wrinkly looking tuberosity here. All right, so this is this bone. All right, and here is the part where it engages into the fibula. So I think this is a tibia-fibula situation. Now, that ball fits in that hole, and then there's a little stalk, and then there's a ball that fits into this bone if it was there. All right, and that makes them so that they can do all that stuff on that little neck that's between them. And I'll show you one. I'll show you a couple of them. Okay, I might as well go right for the chakra du jour. There it is right there. This is that enthesis, and that is the little fiber stalk between the two, so they can wobble a little bit like this. And that's what it is, and it's in space, and it's way, way out in space. So I'm saying this is inside that hole right there, and is locked in with all these little bumps on it, into these little bumps that are in here. and then that one would lock into the other bone that was here, and so they can wiggle around a little bit. This is what it was. So you remember I said this is an anthesis, and this is the same thing, only it's on your spinal cord, so that you can move and jiggle around, and these, it's the same, basically the same thing, only the other one has a ball and a ball inside of two sockets. This is a block and a block and a block up and down. Each one of them can move separately. That's how you can move your spine. This is an injury. All right, that's a stressed injury. Somebody ripped the tendons a little bit, apparently. That's what they're showing. All right, see, this is how research it progresses if you really do good research. This is the Kyper belt. So I'm going out here to research the Kyper belt and why it stops so abruptly. And then I realize there's more than just a Kyper belt. There's another belt way outside here further. That is why it's abruptly pushing the Kyper belt in, because their fields will push against each other. That's what I'm thinking now. And I believe it's the Oort cloud. Yeah, here it is right there. Beyond the Kyper belt, there's also the Oort cloud. They're not showing it here. And this is how I started into this. And then when I started looking at this, I'm reading through it. Yeah, interesting. And then I come to this. And I said, whoa, interesting, yes. That's a ligament anthesis. And he says, why is the Kyper belt important? Because it's got a lot of ligament anthesises out there. All right. Objects with diameters 62 miles or wider. All right, so they were afraid they're going to hit the Earth. 100 trillion comets in the Kyper belt. That's a body part. I'm sorry, it's just what it is. And they think it's a leftover from the... I don't know what they think, to be honest with you. I'm not going to get into that. But that is a body part. So anyway, this was my original thing, was that we're spinning around here, and we're spinning around the sun, and the solar system is spinning around the focal point, which is the sun. And we're still being dragged through the arm of the Milky Way as well. So we're actually trailing the sun. The sun is up here, and we're back here spinning around trying to catch up. That's what I believe. There's a gift that shows it. I'll show you that. See, this is more accurate, I think, because we're being pulled on the arm of the Milky Way. Therefore, the sun is going to be the dominant attractor of all these particles, which are us, and the rest of the planet spinning around trying to catch the sun. Now, outside, way out here, there's these clouds of particles that are the Kyper belt, and then the Oort cloud surrounding that. So there's a lot of dynamics going on. So I really don't have all the answers, or even some of the answers, to be perfectly honest at this point. But that's how you start trying to understand. But I can tell you what, that Kyper belt, that's the one they showed. That's a body part. That's all there is to it. Okay, so don't forget, my claim is that we have a bone to a bone with a little tiny stalk in between. It's much shorter than that. That's just so that you can see that it's here. And this is the ligament. Okay, this is a ligament, and this is the anthesis, which is where it attaches inside. So the anthesis goes into a ball, and the same on the other side. And if you just took the ball that was here and the ball that was here along with the stalk and took it out of there and disintegrated the bone for some reason, you would end up with like a little barbell. And that's exactly what that thing is out in the Kyper belt. All right, so don't forget that it's my claim that the head of the bone attaches to here. We're going to have a ball, a little shaft, and then another ball. That's out in space. The one I have here, which is in the microscope right there, we're going to be looking in at the ball. The ball's still there, but it's snapped off, so we don't have the dumbbell sticking on the other side. But the one in space, all the bone got gone on both sides, and the little dumbbell's still there. So I got to turn the lights off. Hold on. All right, there it is. There's the cavity that I showed you right here. And these were all the little straps came out, and the ball locks in there, and the other one would come right up against it. So this wouldn't be very long. It'd be very short. but the two of them could mix together and move around. And that's what, and it's the same basically as what you see there, all the little fibers coming out of the ball, and it snaps. So you, and that's what it is right there. It's hard to miss. And it's right, and that is a bone. I mean, I just showed you. And it actually has still some little bits of bone left in it that didn't transition yet. But it's obviously a bone anyway, so. That's all we got there, folks. Okay, so I guess that's probably enough for that. We know that this was the two bones locked together. It's just one of those balls and another ball on the other side, making the ligament so that that bone could match up with its other bone. All right, so let's move on from there. This I also have, which is the giant fingertip. DNA tested, and I have the DNA tester online. That is the fingernail, all right? And it's not in bad shape. It's pretty good shape. And that is the little pad that goes in between bones so that they don't rock and crush each other bone to bone. Little pad, that round little pad. That's the blood supplies. This piece here I broke off right on the edge of the fingerprint. And fingernail. I just smashed it with a hammer and it popped right off like it wasn't even hardly attached. And that's exactly what the skin does. It's grip skin. And I'll show you. I have another one that did the same thing. Now, that's the fingertip. It's almost 3 feet long, or I figured it's 3 feet long. That's what I called it, 36-inch tip. So that's one thing. Now, the other side of it is where the fingerprints are. All right, and we're going to be looking at this in a microscope in a minute. I've been promising to do this, and I just didn't get to it. This is nothing more than a sweat pores, and this is a fingerprint ridge, just like you have them on your fingerprints. My thumb is the same size as one ridge. It's like I said, it's 3 feet long, so it's a good size. And again, this popped off just like that peeled off. Only there's a tiny little piece of meat that's still attached. I haven't looked at it yet, but it sure looks that way. We're going to look at this close in a second. So this is the grip skin, which is the fingerprints, just like you have on your hand. And I figured out this guy would have been, I don't know, 180 feet tall, something like that. Because they were supposedly the exact same proportions as us. They were just gigantic. All right, so that's all I can say. And again, this is grip skin, and it peels right off, just like this. And now you can't get blood out of that. You got to get down into where there's blood, and it's saturated with blood. I took the blood out and they said it was excellent quality and dense. Because you got to go right into an artery. You see, fingertips, you can get all the blood you want out of them. They're just saturated with blood. One side comes down the artery, and it filters through, and then it comes back the other side, the vein. So there's a hole here, a hole here, and a hole at the end. And the same thing on the other side. The veins, though, have clamps. They pinch off, so the blood cannot go backwards. And when they do that, they don't empty out. It's not like the red blood. The red blood is wide open, go this way, go that way, go anywhere it wants. And it's very fluidy. And when they died, most of the red blood ran out or, whatever. But, it congealed too. It depends on how the condition they were in and how they were packed up they were when they were entombed, basically. So what have I shown you? That and that and this and this and this and that and this and everything was just gigantic back then. All I can tell you is that as a fact, there's not a single culture on Earth that didn't say the same thing. None. Zero. So I'm going to have to go with that. The Age of Enlightenment was how to start to control people and take you away from the reality of, and after that, the Age of Enlightenment, everybody lost all of the ancient knowledge. It was just gone. And if you started talking about it, they would fail you. So it was really a domination of the mind. It's called menticide, where they dominate you so severely that there's nothing you can do. You have to give in. So don't forget, as far as I'm concerned, everything, the particles here are being thrown out to a distance, and then the Oort cloud is out here. And there's push to shove between regions. And I'm thinking that's what's going on there, but I really don't know, I have to be honest with you. But we got this belt, which gives you a complete drop-off, just like the, that spinning device there, I can't even think about it. I'm telling you, my mind is going. Centrifuge. All right, and the only problem is the centrifuge has an end to it. The tube stops. This should be able to just keep going. But if the Oort cloud is out there, and for some reason that is basically the outside of the tube, you would get this effect. I'm not making any claims. I'm just trying to figure it out. But in the meantime, I'm just having fun learning new things. I didn't know that Kyper belt had body parts in it, just like all the comets. The comets are nothing but body parts too. Asteroids, meteorites, they're all body parts. There's nothing but biology. It's just a fact. If somebody wants to confront me with this and do an online Zoom meeting, somebody that is an astrobiologist or whatever they are, and from NASA, I don't care where they're from, I can show you evidence to support everything I'm saying. So that's what I'd like. All right, this hand is another one that I have here. Now, don't forget, the fingertip is like 3 feet wide, 3 feet long. This is maybe 4 feet-ish, somewhere around there. This is the pad that is your bumper pad on the bottom of your hand right here. Anyway, there's the little cleave that goes between the two bumpers. That's the tendon that runs down. It's your left hand. You've got the same tendon. And then this one here, this little fleshy part runs down to your little finger, and that's the thumb. This is where all the grip skin has eroded away. Remember I showed you how the grip skin just sort of peels off? Same thing here. And then underneath is the fleshy part. Now this has been DNA tested as well, and parts of it have been CAT scan, fingertip, and so forth. So that's that. So this has also been DNA tested. I think I told you that. I'll show you the DNA tests. And I guess that shows pretty much what we got now. You see these colors? They didn't end up here for nothing. This is the same sort of situation as specific gravity. They worked their way down through here during the Great Flood, and the different colors represent the different transition metals, and that's why they're in different layers. These are the different transition metals. They all have a different weight. Specific gravity means you go down to where you're the heaviest one, and then they come stack up from there. And that's what I'm thinking is going on out there in that Oort cloud, in the Kyper belt. But that's why you get all these different layered colors. And there's a lot of places around the world that have all of these different colors in layers. Because the body chemistry is different, and it's going to attract different types of transition metals. All right, so we're going to put this in a microscope. This, again, is the fingertip with the fingerprints on it, and it's like peeled right off of there. There's nothing holding it on. It was just like this and fell right off. I slammed it with a pretty good sized hammer, but it came right off. Now, there is a spot in here, and I believe it's right there, where not only do we have the skin, which the skin is here, we got a little piece of the flesh, I believe, which is down below in this layer. You see it right there? Well, I'm going to put it in the microscope. Let's take a look at it. I haven't looked at it in a microscope, so I don't know, but I think that is. The rest is just the thickness of the skin. That's the thickness of the skin. All right, so we're going to look at it in the microscope right now. Let me get set up. All right, this is it. This is ultra cool. This layer right here is what I'm going to be showing you. And then, like I said, a little piece of this came up with the skin. And I will show you that. But that is what the grip skin looks like. Now that's the surface of the skin, and it has the surface texture of skin, and then right below it is just, there's nothing but this, same as I showed you before, this keratins, keratins. There's no real fleshiness to this. Now, if we come down this way, which I will, we run into the flesh. You see it right there? At the edge, you run into fleshiness anyway. But this was a chunk that broke off. Let me back up here. You see it? That came up with the skin. And normally you don't see that. Hold on. All right, normally you won't see that's come away with the skin, but in this particular case, we got lucky. A chunk came up with it. Now, I'm going to put a little water on there, and we'll see what it looks like when it gets hydrated. But you can see the difference in the fleshiness compared to the grip skin. Totally different. And those little black things in there, I think that's carborundum. And it is tough. I mean, this stuff is just as tough as can be. Unbelievably hard. All right, let's watch this together. I haven't done this yet, but I'm expecting to see a pretty good, look like some kind of fleshy looking stuff. Hold on. Let me come down a little better, closer. We gotta let it dry up a little bit. When it gets wet like that, it's kind of hard to see real good, but right away I can tell that this is sucking up the moisture a lot more because there's a lot more blood in there. This is, literally, there's no blood in there. You can't get blood out of that. There's just none in there. You got to get down here into this flesh, and that is flesh. You really can't see how this is just staying wet because it doesn't absorb, and that's how your skin is. It's just different than the flesh part. Flesh sucks it right up. All right, here's what you're looking at. Remember, this is the part we just looked at coming this way. This is the bottom where it literally just glues. That's just like some kind of glue almost. And it glues to the bottom basement layer with whatever this gluey stuff is. All right. So anyway, that's between the grip skin itself, the really tough grip skin, and the fleshy part below. All right, this is the surface, and you see these little black spots. For some reason, I had it in my notes that was carborundum. Now, I never had any of that stuff tested, but that's what I have now. Carborundum is 9 on the hardness scale, so it's tough stuff. And that's what your grip skin is. It does a lot of work, and that's where you find that those little black spots. I think that's carborundum. Anyway, that's the surface of the skin, and then as you break it and go right down through the layers of the skin, that's it right there. And then, of course, after you finish up through the skin, right, going down here, you get into the fleshy part. And I did show you that little tiny little piece, and that's all that came up. Okay, I'm going to sort of wrap this up. You've seen this a zillion times. This is the erector pili muscle right there. That is the sebaceous gland right there. That is the root ball with the vein and artery right there. And that is the hair shaft. This is from a giant hair follicle. Now, remember I showed you the fingerprints? Well, this is also fingerprints. Only they're a little thicker than the one I showed you before. And these are where the fingerprint ridges go, like this and like that. And that's that Slurpee that just sticks it to, like here, hold on. All right, this is this. Basically, that's that. Now, you can basically see the little ripples they're showing here. That's these little ripples. Let me see if I can bring it in closer. You see these little ripples right here? That's these little ripples right here. And this gives it the ability to move in and out a little bit. And this is what this keratinized part is. It has a little slip over the top, just as mine does. Exactly the same. And then that dark stuff in the middle, and then the Slurpee that sticks it down here. That's a good size fingerprint. That's just one ridge. So the stuff is huge. It's everywhere. It's not just here. So anyway, I'm going to leave it at that for today. But the things in space, you saw what covered Raleigh, North Carolina. You know, that's just, the stuff is unbelievably large. But so are the creatures here on Earth that were here before the flood. The same thing on Mars, the same exact same stuff. There's no difference whatsoever. And as far as I can determine, 100% of everything is from biology at one time. And it just apparently recycles itself, it looks like to me. All right, so anyway, thank you. I hope you enjoyed it. And I love you all. Merry Christmas. And I'm probably going to be doing some more before then, but I don't know. I don't know what I'm going to do. I got to be honest with you. It's become quite frustrating because you know, and people are telling me, "Oh, you keep doing the same thing over and over." Well, that's true, but there's a lot more to learn. I learn something every day, so it's not like I'm just walking around in circles. I am learning more and more as I go forward. But it is frustrating. I got to tell you that. Anyway. Thank you all. I love you, and we'll talk again soon. All right, bye.